time. We treat it like a straight line, as if every second follows another in perfect rhythm. Yet when you leave Earth, when you step out into the silence of space, this line begins to bend, twist, and even slow down. Out there, time is not the same companion we think it is here. Our clocks may tick faithfully on the wall, but the universe keeps a different rhythm. Astronauts, satellites, black holes, each holds a secret about how seconds can stretch or shrink depending on where you are. And maybe the strangest truth of all is this: the universe does not carry a single universal clock. It carries many. Tonight we drift through these mysteries together, not to solve time, but to feel its strangeness, its softness, and its hidden depth. Close your eyes, breathe slower, and let the questions guide you. The quiet puzzle of time itself. Time has always been the most familiar stranger in our lives. We notice it when birthdays come and when seasons pass, but we never hold it in our hands. Philosophers once asked whether time even exists outside our minds. Is it real, or is it just memory playing tricks? Scientists, too, have tried to measure its heartbeat, but each attempt only deepens the riddle. You look at the clock, you hear its tick, yet you know it's not time itself you're hearing. It's only the sound of something trying to capture the uncatchable. When you think about it, time has no taste, no color, no texture. You can't put it in a jar or take it out to examine. You only feel its effect. Your reflection in the mirror, the cooling of tea, the fading of music in the air. This is why humans built clocks, not to understand time, but to tame it. Yet the irony is that the more we try to pin it down, the more slippery it becomes. As though time enjoys watching us chase it in circles. Imagine for a moment if time simply stopped. The wind would no longer move, rivers would hang frozen in mid-air, and our very thoughts might stall mid-sentence. But here's the strange part. How would you even know it had stopped if all knowing itself depends on time? It's like trying to see your own eyes without a mirror. A paradox that teases the mind just before sleep. What makes the puzzle even stranger is that in physics, time is woven tightly with space. They're not two separate threads, but one fabric, space-time. Every movement, every orbit, every ripple in the universe bends this fabric, and with it, time bends too. Which means the seconds you trust so deeply may not be the same seconds someone else is living. A quiet truth that feels almost unfair. Like a game we didn't realize we were playing, and so before we even leave Earth, we're already unsettled. Time is not solid, not absolute, not the same for everyone. But if it's slippery here, just wait until you follow it out into the silence of the cosmos. That's where the puzzle grows louder. How our clocks on Earth learned to tick. The first clocks were not machines, but shadows. Ancient people planted tall stones and watched the sun draw its path across the ground. Time was not minutes or hours back then. It was warmth, light, and seasons, a harvest, a moon, a winter. These were the markers of life. And though it seems simple, there's something profound in the idea that humans once measured time by the length of their own shadows. Later, water clocks appeared. Flowing drops counted the night when the sun could not. Sand trickled in glass bulbs, each grain a whisper of passing moments. And then, with bells and gears, humanity turned time into sound. Church towers rang hours across villages, reminding people that time did not belong to them alone. It belonged to the community. The tick-tock became a heartbeat that everyone shared. But here lies the quiet irony. Even with perfect gears, even with quartz crystals humming steadily, all our clocks are still earth-bound. They keep rhythm by the turning of our planet, by the vibration of atoms, by conditions here. If you take them away, up into orbit, down near a black hole, their steady tick begins to betray them. they lose their loyalty to us. This is why scientists turn to atomic clocks. By measuring the oscillation of cesium atoms, we found a rhythm so precise it would lose only a second in millions of years. Yet even these marvels, the most faithful clocks ever built, confess a strange truth when taken into space. They disagree with each other depending on where they are. Higher up, they run a little faster. Down near Earth's surface, they slow just enough to notice. Same design, same atoms, yet different truth. And it's from this disagreement, this refusal of clocks to match perfectly, that we first stumbled upon the deeper reality. The time itself is not fixed. Our clocks did not fail us. They simply revealed that the universe plays by rules we had not yet imagined. The hidden rhythm that binds our days. If you've ever woken before sunrise, you've felt it. That strange sense of rhythm running through the earth. Birds stir, the sky brightens, your body wakes, even without an alarm. This rhythm is not just habit, but biology. Our bodies carry circadian clocks, internal timers that align with the rotation of the earth, which means, in a very real sense, your heartbeat and your sleep are tied to the turning of the planet. But here's where things get delicate. That rhythm, so natural and strong on Earth, is not universal. Take an astronaut into space and suddenly their inner clocks begin to drift. Without the 24-hour cycle of sunlight and shadow, their bodies float into confusion. Days blur, sleep shifts, and even digestion changes pace. The body itself whispers, time is not only external, it's also something we carry inside. This binding rhythm goes further. Plants open their leaves at dawn, animals migrate with the seasons, coral reefs glow in harmony with the moonlight. The entire biosphere ticks to a drum we cannot hear, but can feel. It's as though the earth itself is a great timekeeper, and we are its dancers moving to the unseen beat. Yet even this grand rhythm is not flawless. Leap seconds must sometimes be added to our official clocks because Earth wobbles. Its rotation is not perfect, and so our shared rhythm is always in slight tension with the universe. We live with the illusion of order, but beneath it lies gentle chaos, a reminder that our sense of time is stitched together, not born complete. So when we talk about time moving differently in space, we must first remember that even here, at home, time is already uneven. We live by a rhythm, yes, but it is one tuned to Earth. Step away from Earth, and the rhythm shifts. Einstein whispers that time is not fixed. Before Einstein, time was thought to be absolute. Newton imagined it as a universal river, flowing evenly everywhere, but Einstein looked closer and he saw cracks. He realized that the flow of time depends on two things: speed and gravity. This was not philosophy, it was math, proven again and again by experiments. The faster you move, the slower your clock. The stronger the gravity you feel, the slower your seconds. This idea shocked the world. If you fly near the speed of light, time bends. A twin on Earth grows older while a twin in space lingers in youth. Time, once thought untouchable, now seemed elastic. And what was most unsettling is that this was not a trick of perception, but that it was real. The seconds themselves stretched, the heartbeats themselves slowed. A truth both beautiful and uncomfortable. Einstein's equations also whispered another secret. Space and time are not separate. They are one thing, space-time. A fabric that bends under the weight of stars and planets, curving not just matter, but moments. Walk across a curved space and your path changes. Live within curved space-time and your time changes too. What we thought was solid became flexible. Even now, the evidence surrounds us. Satellites orbiting Earth must account for relativity, or their clocks drift. Astronauts age microscopically slower than their families back home. The universe has always played this trick, but only recently did we have the tools to notice. It's like discovering a hidden rhythm that was always there in the background, waiting for us to tune in. And the strange comfort is this: if time is flexible, then so is our experience of it. We are not trapped in one rigid flow, but swimming in a current that bends and twists. A current far stranger than we ever thought. The strange dance of speed and stillness. Picture a train racing through the night. Inside, passengers chat, sip tea, laugh. To them, time feels normal, but to someone standing on the platform watching the blur of windows, their time is not quite the same. Einstein showed us that as the train goes faster, its passengers' clocks tick a little slower compared to those standing still. This is not just imagination, as we go, it is measurable, tested with speeding particles and precise clocks. The faster you move, the more stubbornly your time resists. A particle near the speed of light can live longer than it should, as if its seconds are stretched out. Meanwhile, the still observer watches it drift by, puzzled that the particle refuses to decay as expected. Speed in this sense is not only motion, it's a way of bending the fabric of reality, a quiet defiance against the ordinary flow. But what about stillness? Is there such a thing as absolute rest? In truth, no. Motion is always relative. A person sitting in their chair feels still, yet Earth itself is spinning at thousands of kilometers per hour, orbiting the sun, hurtling through the galaxy, which means, whether you like it or not, you are always moving, and therefore always playing with time. The strangeness lies in the fact that both the moving and the still are correct. Each has their own time, and both times are true. This is the dance. No single observer holds the ultimate rhythm. The universe allows many truths to coexist. You might think you share the same second as someone else, but in the deepest sense, you do not. And so speed and stillness become illusions. Each perspective carries its own ticking clock, each just as real as the other. The dance of relativity hums quietly beneath every journey, whether by train, plane, or starlight. When motion bends the minutes we feel, we think of running down a street at night. Your heart races, the world blurs, but the clock on the wall at home does not care. Yet in the realm of physics, motion itself bends minutes. The faster something moves, the slower time flows for it compared to those standing still. This isn't a trick of eyesight, it's a real stretching of seconds. Pilots flying high-speed jets return a fraction younger than those who remained on the ground. It's almost invisible in daily life, but the deeper you look, the stranger it becomes. Scientists have tested this truth with tiny particles that live only a blink before decaying, send them hurtling close to light speed, and suddenly their short lives are stretched. They live longer than expected, not because they want to, but because time itself slows down around them. It's unsettling to imagine that your pace through space can change your pace through life. Yet that's exactly what the universe allows, a secret bargain between motion and time that no human can escape. What's even more mysterious is that you don't feel it happening. The runner feels normal, the pilot feels normal, the particle itself feels no delay. Inside their frame, time ticks the same. It is only from the outside, from the still observer's eye, that the difference emerges. This hidden dance makes us wonder how many versions of normal are playing out in the universe right now. Perhaps billions, each with its own truth, each just as real as the next. If you extend this idea further, the implications become almost poetic. Imagine a spacecraft leaving Earth at near light speed. Its crew would feel a year pass. But when they returned home, decades or even centuries might have passed for those they left behind. Their minutes bent, their hours stretched, not by choice, but by motion itself. Suddenly, speed is no longer about distance. It's about sculpting time. Every journey becomes a carving in the fabric of seconds. This bending of minutes tells us something profound. Time is not a universal law we all share equally. It's a flexible experience that depends on how we move. Some people walk, some run, some orbit at thousands of kilometers per hour. And all of them live in slightly different realities of time. Once you realize this, the ticking of a clock feels less like certainty and more like a suggestion. Gravity's invisible hand, tugging at the clock. Gravity is not only about pulling apples to the ground or keeping planets in orbit. It also pulls on time itself. The stronger the gravity, the slower time moves. Clocks near the surface of Earth tick more slowly than clocks high in orbit. And this is not theory, it's measured, confirmed, undeniable. Gravity's hand does not just weigh on our bodies, it presses gently on our seconds. This means that your head is technically living slightly faster than your feet. It sounds absurd, but atomic clocks placed at different heights have revealed it. Lift one just a few centimeters and it ticks a tiny bit faster than the one left below. A difference so small we don't feel it, yet so real it changes how satellites must operate. The universe doesn't play by our common sense. It whispers its secrets only to those who listen carefully. Think of a black hole, the heaviest anchor of gravity. To fall into its pull is to fall into slow time. To a distant observer, your seconds stretch, your fall takes forever. Yet to you, the fall feels normal. Gravity is tugging at the clock, stretching it like taffy. And suddenly, eternity and moments blur into one another. The deeper the gravity, the deeper the distortion of time. This truth has, everyday, consequences. The GPS in your phone works only because engineers account for gravity's tug. Without adjusting for relativity, your location would drift by kilometers each day. Every map you use, every path you follow, is proof that gravity bends not just your body, but your minutes. The Earth itself becomes a sculptor, reshaping time as gently as it reshapes rivers. So when you look at the stars, remember, they are not just distant lights, they are masters of time, bending it quietly, invisibly, shaping the very rhythm by which the universe breathes. Gravity does not only pull on matter, it pulls on the flow of reality itself. Why mountains and valleys make seconds uneven. Imagine standing atop a mountain peak. The air is thin, the horizon wide, and yet time itself is running just a little faster for you than for someone down in the valley below. This is because gravity weakens as you rise higher, and weaker gravity allows clocks to tick quicker. It means your seconds stretch slightly differently than the seconds of someone at sea level. Mountains and valleys are not only landscapes, they are different time zones hidden inside the same place. This idea feels almost mischievous. Two friends can start a stopwatch together, one climbing upward, the other staying below. When they reunite, their stopwatches disagree, not because of error, but because they lived through slightly different versions of time. The mountain does not just give you a view, it gifts you a different rhythm of reality. And though the effect is minuscule, it is undeniable. A reminder that time is not equal everywhere, even across a few hundred meters. Pilots flying commercial jets live this reality too. Spending long hours at high altitude, their clocks tick a tiny bit quicker than those of people on the ground. Over a lifetime, the difference adds up to nanoseconds. Nothing dramatic, but proof that time itself refuses to be uniform. Even our everyday world hides these secret mismatches, as though Earth is constantly reminding us of the strangeness beneath our normal lives. The beauty of this truth is that it shows how fragile our sense of equality in time really is. We assume that seconds are shared, that moments pass the same way for everyone, but they don't. The valley dweller and the mountaintop wanderer live in slightly different realities. Which makes us wonder, how many invisible differences are we missing in the flow of everyday existence? And the most humbling thought is this: if a simple climb up a hill can shift time, what happens when we look beyond Earth, where gravity changes wildly, where distances grow immeasurable? Our planet is only the opening act of this mystery. The deeper truths lie out in the cosmic stage, the falling apple and the bending fabric of time. A simple apple once led Newton to describe gravity as a force pulling things down. But centuries later, Einstein saw it differently. He realized gravity is not just a force, it's the bending of space-time itself. The apple does not fall because the Earth pulls it, but because Earth curves the fabric around it. And as this fabric bends, so does time. Falling is not just motion in space, it's also motion through time's curve. Picture a trampoline with a heavy ball resting in the center. Place a smaller ball nearby and it rolls inward. To us, it looks like attraction, but in truth, the smaller ball is simply following the curve of the surface. That's how space-time works, and time, being part of that surface, bends right alongside it. The apple doesn't just fall, it falls into a distorted rhythm of seconds, a path carved not just in space, but in the very flow of reality. This vision changed everything. No longer was gravity a simple pull. It became geometry. It became the shape of the universe itself. And with that shift came an unsettling thought. Time, which we once thought was steady and straight, is actually a river that curves around stars, flows slower near planets, and stretches endlessly across the void. What feels like a simple drop of fruit is a window into the grand design. Even more astonishing, this bending fabric is not just theory. We see its effect in starlight that bends around the sun during an eclipse, in satellites that drift unless adjusted, in clocks that refuse to stay synchronized. The universe constantly proves the fabric is real, and that time, like space, is woven into its folds. So the apple that once inspired Newton continues to inspire us. It whispers that gravity and time are the same story, told in two languages. And to truly understand one, you must listen to the other. This falling apple connects us not only to Earth, but to the very structure of the cosmos. Satellites orbiting faster than our watches below. Far above our heads, satellites circle Earth with silent patience. They look ordinary, but their clocks are not. Up there, away from Earth's strongest gravity, time runs faster for them than for us. Yet because they also move at tremendous speeds, their motion slows their clocks at the same time. One effect speeds them up. The other slows them down. And together, these competing truths create a delicate balance that must be accounted for every second. The GPS system is the clearest proof. Those satellites beam signals to your phone, guiding you to your destination. But if we ignored relativity, and if we assumed time ticked the same everywhere, your location would be off by kilometers each day. The maps you trust, the directions you follow, all depend on correcting for the bending of time. It's an invisible adjustment that quietly shapes modern life. What's remarkable is that satellites reveal relativity not as abstract theory, but as daily necessity. Every driver, every traveler, every delivery van depends on these tiny corrections, and yet most people never realize they're using Einstein's ideas with every step they take. Our phones don't just connect us to each other. They connect us to the truth that time is not universal. Think of it this way: the world you live in is stitched together by disagreements in time. Your phone, your maps, your signals, they are all products of a universe where seconds are slippery. Without satellites orbiting with their altered clocks, you would be lost, literally. Our trust in technology is, in truth, a trust in relativity. So next time you glance at your GPS, remember, those satellites are not just spinning above you. They are living in a different time, moving at a different pace. And yet, together, they make your world feel steady. This harmony of mismatched clocks keeps your life running smoothly. Why astronauts return younger than their twins? The twin paradox is one of those thought experiments that seems like a riddle, yet it is a real truth of physics. Imagine two identical twins. One stays on Earth, the other boards a spacecraft and travels close to the speed of light. When the traveler returns, they will be younger than the one who stayed behind. It sounds like a storybook twist, but experiments with clocks and jets have proven it. Space travelers really live through slightly less time than those at home. For astronauts orbiting Earth, the effect is tiny but real. Spending months aboard the International Space Station, they age a fraction slower than their families on the ground. The difference may only be milliseconds, yet it exists. This is not science fiction, it's physics, whispering that motion and gravity conspire to sculpt different timelines. Astronauts, in a sense, are time travelers, moving forward at a slightly slower pace than the rest of us. What's haunting is that no one feels it happening. The twin in space laughs, works, and dreams the same as their sibling on Earth. But their clocks disagree. When they embrace again, the bond of family is the same, but their lived seconds are not. A gap has opened, subtle, silent, yet impossible to deny. This paradox invites us to rethink aging itself. If speed and gravity can slow time, then age is not a fixed truth of biology, but an experience woven into space-time. Perhaps the face in the mirror does not tell the whole story. Perhaps age is not only about years, but about where and how you lived them. And if this is true, then every astronaut who leaves Earth carries with them not only the hopes of humanity, but also a strange gift, the gift of living just slightly outside of our shared rhythm. A reminder that even among family, even among twins, time is never fully equal. The delicate adjustments behind GPS maps. It may seem ordinary when you open your phone and see a blue dot guiding your steps. Yet that blue dot exists only because engineers account for relativity. Satellites orbit higher, where gravity is weaker, so their clocks tick faster. But they also move quickly, which slows their clocks. Without adjusting for both effects, GPS would drift by kilometers each day. Your navigation would collapse into chaos. Every direction you take relies on correcting time itself. These corrections are not guesses, they are precise, constant, and essential. Atomic clocks aboard satellites are compared and recalibrated to align with Earth's clocks. It is a dance of synchronization across different layers of space-time. Engineers become quiet guardians of relativity, making sure your morning commute unfolds smoothly. Without their work, the invisible distortions of time would scatter us all. What's breathtaking is that most people never realize this. Millions rely on GPS daily: pilots, farmers, hikers, drivers. Without knowing, they are leaning on Einstein's ideas. The map on your phone is not just a convenience. It is proof that relativity is not abstract but practical, woven into the way we move through our days. Imagine how astonishing it would have been to Einstein himself. A century ago, his ideas were considered strange, even impractical. Today they are folded into your pocket, guiding you across cities. Relativity has quietly become part of daily life, not through grand demonstrations, but through simple directions. Every turn left and you have arrived is a whisper from the universe. Time does not flow the same everywhere. And so GPS is more than technology. It is a living reminder that our world is stitched together by different clocks, constantly adjusted, constantly reconciled. Without this harmony of disagreement, our blue dot would vanish and our sense of place would dissolve. How your phone silently negotiates with relativity. Each time your phone connects with satellites, it does something extraordinary. It compares signals, accounts for delays caused by distance, and corrects for the distortions of gravity and motion. All of this happens silently in milliseconds without you ever noticing. Your phone is not just a device, it is a negotiator, constantly making peace between different versions of time. What's fascinating is how natural it feels. You tap a screen, the map responds, and you move with confidence. Yet behind that smooth surface lies a constant war of seconds. One clock ticks in orbit, another ticks on Earth, and your phone sits in the middle, reconciling them. It is like a translator between languages that should not align, yet somehow do. This negotiation happens billions of times a day across billions of devices. Each moment, relativity is being corrected in real time for ordinary people, delivery drivers, students, travelers. It is science at its most humble, invisible, quiet, reliable. You don't think of Einstein while checking traffic, but his fingerprints are there in every calculation your phone makes. Sometimes I wonder how fragile it all is. If these corrections failed, if relativity were ignored, our entire system of navigation would crumble. Planes would wander, ships would drift, even financial networks that depend on precise timing would falter. A reminder that our modern world is not just built on steel and electricity, but on the delicate balance of time itself. And perhaps the most moving truth is this: in a small way, your phone keeps you connected not only to the Earth, but to the universe. Every signal it catches is a thread from the stars above, adjusted, woven, and delivered quietly into your hand. Light as the silent ruler of cosmic timing. When scientists measure time, they often use light as the ultimate ruler. A beam of light moves at a constant speed, unaffected by mass, always steady across the void. No matter where you are, no matter how fast you travel, light refuses to change its pace. And this stubborn consistency is what makes it the foundation of cosmic timing. It is the silent metronome against which the universe plays. Every experiment in relativity depends on light. When we say motion slows time, we prove it by watching light behave differently for different observers. To one, the beam stretches longer. To another, it races straight. Both are correct, yet light itself never wavers. It bends with space-time, but it never betrays its speed. That constancy becomes the anchor of all timing. Even the definition of a second is tied to light. Modern atomic clocks count vibrations of cesium atoms, which are connected to electromagnetic radiation, a cousin of light itself. Every tick, every second, is ultimately derived from the universe's unwavering beam. In a sense, light does not just illuminate space, it illuminates time. And here is the strange beauty. When we look at distant stars, the light that reaches us carries not only distance, but history. A star 100 light-years away shows us its past self 100 years ago. Light reveals not only where something is, but when it was. It becomes both ruler and messenger, collapsing space and time into a single thread. So, the next time you see sunlight spilling across a window, remember, you are not only seeing light, you are seeing the heartbeat of time itself, the same ruler used by the cosmos, steady and faithful, carrying the rhythm of eternity into your everyday life. When photons stretch across the expanding sky, the universe is expanding, and with it, the light traveling through it is stretched. This stretching turns sharp blue light into gentle red, a phenomenon called redshift. Every photon that leaves a distant galaxy carries not only its brightness, but also the slow widening of space itself. As the universe grows, light grows weary, its waves lengthening like sighs carried across a great distance. This stretching of light is not just a curiosity. It is our primary evidence that the universe is expanding at all. Galaxies recede, not because they speed through space, but because space itself is swelling, carrying them apart. And as it does, the photons they send to us are pulled wider, softer, slower. Each one becomes a thread, stretched by the fabric of the cosmos. What's profound is that this stretching also stretches time. The flicker of a distant supernova, the pulse of a star, reaches us in elongated rhythm. What once happened in seconds arrives as minutes. What once happened in days reaches us as years. The universe itself is slowing the heartbeat of distant events, turning moments into echoes. When you gaze at the night sky, you are not seeing it as it is. You are seeing it as it was, slowed down, softened by expansion. Every star is a memory, every galaxy a history lesson, every photon a stretched letter from the past. The farther you look, the older the message becomes, until you are reading from the dawn of time itself. And perhaps that is the most humbling truth. The universe does not only contain history, it delivers it gently, patiently, in stretched-out whispers of light. Time, distance, and expansion all merge into a cosmic language, and we are the listeners, forever reading messages sent across the widening sky, the slow, fading heartbeat of distant galaxies. Look out at a galaxy millions of light years away, and you're not just seeing light, you're seeing rhythm. Every flicker of a star, every pulse of a supernova arrives at your eyes, stretched and softened. What once was sharp now feels like a slowed heartbeat. The farther away the galaxy, the slower its rhythm becomes. It's as though the cosmos itself is singing in slow motion the farther you listen. This fading heartbeat is no illusion. Astronomers measure it. The redshift of galaxies tells us not only that the universe is expanding, but that time itself is woven into this stretching. A single second in that galaxy does not match a second here. Their heartbeats echo differently, creating a choir of rhythms across the universe. Each galaxy carries its own tempo, its own way of experiencing the passing of moments. What's unsettling is that the deeper we look, the slower those heartbeats appear. A distant explosion might last seconds where it occurred, but by the time its light reaches us, it lingers, smeared across hours or even days. Time, in this sense, is not just personal, it is cosmological, altered by distance itself. The night sky is a record of slowed-down music, and yet there's beauty in this softening. Imagine a cosmic drumbeat that slows as it travels, still heard even billions of years later. Without this stretching, without this patience, we might never have seen the faint signals of ancient galaxies at all. The slowness is not loss, it is survival, allowing their stories to reach us across impossible distances. So when you see the hazy glow of galaxies in the night sky, remember, you are not watching them live. You are listening to their slowed, stretched-out heartbeats, delivered carefully across time and distance like lullabies from the edge of forever. Black holes turning time into molasses. Black holes are not just strange because they swallow light. They are strange because they swallow time. Near the event horizon, at the invisible boundary, seconds themselves become sticky, sluggish, almost frozen. To an outside observer, anything falling in appears to slower, until it nearly stops. It is as if time itself thickens into molasses, refusing to let go. But inside, the story is different. For the falling traveler, time feels normal. They drift across the horizon without noticing anything unusual, and yet to everyone watching from outside, they seem to hang suspended forever. This split is not a trick of perspective. It is a fundamental truth. Time does not move the same near a black hole as it does far away. The deeper the gravity, the deeper the distortion. A clock near a black hole would tick slower than one far away. A heartbeat close to the horizon would stretch endlessly for the distant observer. This is not theory. It has been confirmed by the mathematics of relativity and hinted at by the signals we receive from the edges of black holes. What this means is almost poetic. Black holes are not just prisons of matter, they are prisons of time. They trap the future and warp the present. They show us a universe where seconds are not guaranteed, where the very flow of reality can be reshaped by weight alone. In their silence, they whisper truths about the fragility of time itself. So when you imagine a black hole, don't just picture darkness. Picture a place where clocks betray you, where eternity and a single moment blur together, where time itself dissolves into something unrecognizable. The event horizon where future and present blur. The event horizon is the boundary around a black hole where escape is impossible. But it is more than a border. It is the place where time and space trade identities. To those falling in, the horizon is crossed without drama. But to those outside, the fall stretches into forever. This contradiction makes the horizon feel like a place where future and present overlap, where one person's now is another's never. Imagine watching a friend approach a black hole. To you, their movements slow until they seem frozen on the edge. Their light grows redder, dimmer, until it fades into darkness. Yet to your friend, they have already crossed, already fallen, already moved beyond the horizon. Two truths exist at once, each real, each irreconcilable. This is the strange poetry of relativity. Scientists have long debated what happens beyond this boundary. Does time end? Does it continue in some twisted form? The answers remain hidden, guarded by the silence of black holes. What we do know is that horizons blur our definitions of past, present, and future. They reveal that time is not a single river, but many streams running side by side. This blur forces us to ask a haunting question. Is now really the same for everyone? Or is it an agreement we make only because we live far from horizons? Near a black hole, that agreement falls apart. Now becomes relative, fragile, almost meaningless. The present itself fractures into many versions. And so the event horizon is not just a cosmic boundary, it is a mirror showing us the limits of our understanding of time, a reminder that what feels absolute in daily life may dissolve entirely at the edges of the universe, falling into the place where seconds lose meaning. To imagine falling into a black hole is to imagine the unraveling of time itself. For you, the fall would feel quick, almost ordinary. But to anyone watching from afar, you would stretch across eternity, your final moments frozen in a loop. Seconds would lose meaning, replaced by a strange limbo where beginnings and endings blur. The deeper you fall, the slower your clock ticks relative to the universe. A second for you might become centuries for others. Entire civilizations could rise and fall while you drift those last few meters. In this sense, black holes are not just objects. They are theaters where time stages its most dramatic illusions. But perhaps the strangest thought is this. Once you cross the horizon, the distinction between space and time shifts completely. Moving forward becomes like falling downward. Every path leads to the singularity. Choice dissolves. Seconds collapse. Time itself becomes a direction you cannot escape, pulling you inward as surely as gravity pulls you down on Earth. For physicists, this raises unsettling questions. If time can lose its meaning near a black hole, is it truly fundamental, or is it a construct, something that emerges only under certain conditions? Perhaps time, like music, is only rhythm played on the instrument of space-time, and black holes are where the song breaks apart. To fall into such a place is to confront not just death or darkness, but the possibility that time itself can unravel. A haunting reminder that what we call seconds may be far more fragile than we ever believed, escaping gravity's cage with stretched out hours. If black holes show us how time can be slowed by gravity, then escaping gravity shows us the opposite. The farther you move away from a planet or star, the faster your clock runs compared to those left behind. It means that out in deep space, away from heavy masses, hours stretch out, seconds pass quicker, and you live in a faster rhythm than those anchored to a planet's pull. Astronauts already experience this in orbit. Their clocks tick faster than ours on Earth, though the effect is partly cancelled by their speed. If we sent them farther into interplanetary space, their hours would stretch even more. To them, everything feels normal, but when they return, the world they left behind will have lived slightly slower. Gravity's cage keeps us bound to its tempo, while space offers a freer, faster rhythm. This truth has a quiet beauty. It means the universe does not force a single rhythm on all its children. Instead, it allows each place, each environment, to hold its own version of time. A galaxy core, dense with gravity, ticks slow. The outer void, silent and empty, ticks fast. Together they create a symphony of clocks, each beating its own way through eternity. What this reveals is profound. Escaping gravity is not just movement in space, it is movement in time. To drift higher, to float freer, is to step into a different flow of seconds. Space does not just offer distance, it offers new versions of life itself, played out at different speeds. And as we continue to reach upward, through satellites, through space stations, perhaps one day, through interstellar travel, we will discover not only new worlds, but new ways of living in time. Hours stretched, seconds reshaped, all reminding us that our earthly sense of time is only one small rhythm in a cosmic symphony. Why the universe cannot agree on a single clock? On Earth, we like to think there is one shared clock, one rhythm binding us all, but the universe does not work that way. Time is local. Every star, every planet, every observer moves with its own pace. There is no cosmic master clock keeping everyone in sync. Instead, reality allows billions of different clocks to tick together, each equally valid. It is like listening to an orchestra where every instrument plays its own tempo, chaotic yet strangely harmonious. This disagreement is not a flaw, it is a feature of the universe itself. Relativity teaches us that two observers in different places, moving differently or feeling different gravity, will never agree on the passage of time. They might both believe in their own seconds, but when they meet, those seconds will not align. It's unsettling to think of time as negotiable, yet this is how reality behaves. Astronauts, satellites, even your head and your feet disagree on time. And still, life continues smoothly as if we all agreed. This is the paradox of existence. Billions of mismatched rhythms somehow create the illusion of a single flow. We live in a world of clocks that refuse to match, yet appear united. What's humbling is that even the laws of physics respect this localness. Equations describe the universe without needing a single clock. They allow many truths to exist at once, many rhythms side by side. The cosmos is not ruled by one timekeeper, but by countless ones. It is democracy written into the very structure of reality. So when you look at your watch, know this: it tells you your truth, not the universe's truth. Beyond Earth, beyond your wrist, there are infinite other clocks disagreeing, yet coexisting, like quiet voices in a cosmic choir. The paradox of simultaneity across the stars. If you and I clap our hands at the same moment, we feel it as simultaneous. But what if we are light years apart? Relativity shows that simultaneity is not absolute. What looks like now to you may not be now to me. For two observers moving differently, the order of events itself can shift. A star exploding here and a comet passing there may happen in one order for me and the opposite for you. This is called the relativity of simultaneity, and it breaks our common sense idea of time. We like to think of the universe as a stage where events happen in one shared sequence, but physics says there is no universal stage. Instead, there are many overlapping stages, each with its own order, each valid, each unshakable. Now dissolves into perspective, no longer a single truth, but many. Imagine two astronauts drifting apart in space. One sees lightning strike at two places and calls them simultaneous. The other, moving differently, insists one happened first. Both are correct, yet they disagree. It's not opinion, it's reality. The universe allows multiple orders of the same events. Our sense of certainty is humbled by this quiet contradiction. This paradox changes how we think of history itself. If simultaneity is relative, then the idea of one shared timeline collapses. The universe does not keep a single book of events, but countless versions stitched together by observers. What we call history is not one line, but a patchwork quilt, woven differently depending on where you sit. And perhaps the most haunting thought is this. When we say at the same time under the stars, we may be speaking a local truth, not a universal one. The cosmos, in its vastness, refuses to give us a single now. One astronaut's second is another's eternity. Picture two astronauts, one orbiting Earth, the other traveling toward distant stars at near light speed. To the traveler, a second may pass quickly, but when they return, those same seconds have unfolded into years for the one who stayed behind. One person's fleeting moment is another's eternity, and both are real, both are truth. This is the deep strangeness of time. It bends, stretches, and refuses to belong to everyone equally. This difference is not fantasy. Experiments confirm it. Clocks flown on airplanes return out of sync with those left behind. Satellites require constant corrections. Even the GPS in your hand carries proof that not all seconds are equal. One astronaut's time may slip past like water, another's may drag like honey. Neither can claim to be right or wrong. They simply live in different slices of space-time. The unsettling part is that they may not even notice. Each feels normal, each feels steady. It is only when they compare, when they meet again, that the fracture is revealed. Suddenly, shared memories no longer align perfectly. One has aged more, one has lived less. The bond of friendship remains, but the flow of time has betrayed them. This is why the universe feels almost unfair. We want time to be equal, to promise us all the same number of moments. But physics whispers otherwise. Time is not a promise, or wafi, it is a perspective. Some live shorter but faster. Some live longer but slower. Each carries their own rhythm shaped by motion and gravity. And so one astronaut's second truly can be another's eternity. It is not science fiction. It is the quiet truth written into the laws of reality, a reminder that even the most ordinary moment may be extraordinary depending on where you stand. The cosmic stage, where distance creates delay. When you call a friend across the world, the signal lags by fractions of a second. It's small, almost unnoticeable, yet it reminds us that distance always creates delay. Now imagine calling across space. The farther you go, the greater the delay. Speak to Mars, and you wait minutes for a reply. Reach toward the stars, and your words may never return in your lifetime. Distance does not just stretch space, it stretches the experience of time itself. This delay means we never see the universe as it is now. We see it as it was, depending on how far away it lies. Even the sun we trust each day is already 8 minutes old by the time its light touches Earth. Every star in the night sky is history, every galaxy a museum of past events. The cosmos never shows us its present, it only shows us its memories. What's haunting is that the farther you look, the older those memories become. Galaxies millions of light years away show you their youth, frozen long ago. You might look at a star tonight that has already died. Yet for you it shines, a ghost burning across the sky. Distance creates delay, and delay creates illusions of the past, stitched into the present. This truth is not just poetic, it shapes science itself. Astronomers must account for these delays when studying the universe. Every observation is time travel backward, not into fiction, but into reality. Telescopes are not just windows, they are time machines carrying us through billions of years with each glance. So, when you raise your eyes to the heavens, know this: you are not seeing the universe as it is. You are seeing the universe as it was, painted across the sky in light delayed by distance, a cosmic stage where past and present forever intertwine. Why, signals from Mars already carry the past. Mars feels close, just another planet in our neighborhood. Yet even here, distance reshapes time. Radio signals between Earth and Mars take anywhere from 4 to 24 minutes to travel, depending on their positions in orbit. This means every command, every reply, is already part of the past by the time it arrives. Mission Control never talks to Mars now. They talk to Mars as it was minutes ago. For rovers crawling the Martian surface, this delay is a constant challenge. Engineers cannot drive them in real time. Instead, they send instructions, wait, and trust. By the time the rover responds, the moment has already changed. Each exchange is a dialogue with memory, not with the present. Mars is close, yet it might as well be centuries away in terms of communication. This delay makes exploration both humbling and poetic. We imagine ourselves as explorers of other worlds, yet we are always chasing their past. Mars is never live to us. It is always a recording, slightly old, slightly faded, stitched into the fabric of delay. Our vision of it is not the world as it breathes now, but the world as it breathed minutes before. And the farther we dream of traveling, the deeper this problem becomes. To speak to Jupiter, hours. To speak to a star, lifetimes. It means that in space, conversation itself becomes impossible. You can only ever listen to echoes, never to a true present. The universe insists on silence between voices. So when you see images from Mars, dusty hills, wandering robots, alien sunsets, remember, you are not seeing what is happening right now. You are seeing what has already happened, a message carried across the void, a photograph always a little older than the moment itself. How looking up is always looking backward. Every time you tilt your head toward the stars, you are not looking into the present, you are looking into the past. The light reaching your eyes tonight has been traveling for years, centuries, even billions of years. The star above you might not even exist anymore, yet it still shines in your sky. The heavens are a memory bank, and when we gaze upward, we become witnesses to what once was, not what is. This backward gaze is inescapable. Even the moon you see tonight is already over a second old by the time its light touches you. The sun, warm on your skin, is already 8 minutes in the past. The deeper you look, the older the story becomes. Looking up is never looking at now. It is always listening to echoes stitched into light. This idea shifts our place in the cosmos. We are not just stargazers, we are time travelers, collecting histories that reach us long after they occurred. Each twinkle is a chapter, delayed but preserved. The stars are not random points, they are storytellers, speaking in light that has crossed unimaginable distances to find us. And so the night sky becomes less about space and more about memory. Every glance upward is an act of archaeology, peeling back layers of cosmic time. With each star, each galaxy, we are uncovering what has already happened, piecing together a story written long before humanity ever existed. The wonder is this: in the act of simply looking, you are reading the universe's diary, a page from the past written in the quiet ink of starlight. The sky is not just above you, it is behind you, a reflection of time itself. The universe is a living archive of time. If the sky is backward-looking, then the universe itself is an archive, a vast library where every photon is a record of something that once was. From the faint glow of ancient galaxies to the microwave whisper of the Big Bang, the cosmos stores its entire history in light. We don't need to guess what happened billions of years ago. The evidence still travels toward us, faithfully, patiently, across unimaginable distance. This living archive is unlike any human library. Books fade, paper burns, but starlight endures. A photon created when dinosaurs roamed Earth might still be rushing across the void, untouched, unchanged, waiting to be caught by a telescope. Time does not erase in the universe. It preserves, carrying every moment like a letter, never lost in the mail. Astronomers act like librarians of this cosmic archive. Telescopes are their reading lamps, catching photons and interpreting their stories. Each wavelength tells of heat, motion, distance, age. The deeper they look, the older the chapters become. At the farthest edge, they find the beginning itself, the first flicker of light that marked the dawn of time. But this archive is not static, it is alive. New stars are born, new galaxies collide, new signals begin their journey. The library of light is constantly expanding, constantly rewriting itself. Every moment adds another record, another photon, another entry in the universe's endless memory. Time and history are not separate here, they are the same. So when you stand beneath the night sky, you are not just a spectator. You are standing inside the greatest archive ever built, surrounded by stories billions of years in the making, still arriving, still unfolding, still alive, with memory, supernova light, still arriving long after death. When a star dies in a supernova, it ends in brilliance. The explosion rips across space, brighter than a billion suns, scattering elements that one day form planets and life. But the light from that death does not die quickly. It keeps traveling long after the star itself has vanished. Centuries later, millennia later, the glow still reaches us. We can watch a star's death, even when the star has been gone for ages. This is the strange beauty of light. It carries not only information, but persistence. Supernovae seen today may have occurred before humanity ever walked the earth. Yet only now does their final brilliance touch our eyes. It is as if the universe refuses to let death go unnoticed, broadcasting a farewell that lasts across time. When we catch these dying lights, we don't just learn about stars, we learn about ourselves. The iron in our blood, the calcium in our bones, the gold in our rings, all were born in such explosions. The light we see is a reminder that death in the cosmos is never final. It is transformation, rebirth, the scattering of seeds for future life. Imagine it. A star dies in silence, alone in the void, and yet its light continues to travel, continues to tell the story. Long after the event, long after the place itself has changed, the echo remains. Watching it is like reading a letter from a loved one who is long gone, their voice carried forward beyond their time. So when astronomers record the light of a supernova, they are not watching death, they are watching memory. They are catching a moment stretched across eternity, proof that nothing in the universe truly disappears without leaving a trace of itself behind. The sky filled with ghostly echoes of yesterday. Look up, and the night sky glimmers with stars, but many of those stars are not there anymore. Some have burned out, some have exploded, some have faded into quiet remnants. What you see is their echo, their ghost, still shining, because light takes time to travel. The sky is not a live show, it is a recording, filled with yesterday's voices, still speaking long after the singers are gone. This realization gives stargazing a haunting beauty. Every star you admire may already be a ghost, its true self long vanished. And yet to you it sparkles as if alive, as if present. Light refuses to accept finality. It insists on carrying the memory, keeping stars alive in the eyes of those who watch from afar. This ghostly sky teaches us humility. We humans think of presence as immediate, as live. But the universe laughs at that notion. Presence is always delayed. What you call now in the sky is already gone. The stars deceive you kindly, allowing you to see what no longer exists. It is both a lie and a gift, both tragic and comforting at once. Even galaxies we admire are echoes, their spiral arms perhaps already twisted into new shapes. We do not see them as they are, but as they were when their light began its journey. To gaze at the night sky is to gaze at ghosts. Beautiful ghosts, shining softly in memory. And perhaps that is why the stars move us so deeply. They remind us that nothing truly disappears. Every presence leaves an echo, every life leaves a light. And those echoes continue long after silence. The microwave whisper left from the beginning. Beyond stars, beyond galaxies, there is a faint glow that fills the universe. It is not bright, it is not sharp, it is a soft whisper of microwaves coming equally from every direction. This is the cosmic microwave background, the afterglow of the Big Bang itself. It is the oldest light we can see, a snapshot of the universe when it was only 380,000 years old. Looking at it is like holding the baby picture of existence. This whisper was discovered by accident in the 1960s when two engineers found a strange static in their antenna. At first, they thought it was noise, maybe even pigeons nesting inside. But soon it became clear they had stumbled upon the oldest light in the universe, a gentle signal that had been traveling for nearly 14 billion years, waiting patiently to be found. The cosmic microwave background is not just old, it is uniform, filling every corner of the sky. No matter where you look, it greets you with the same faint signal. It proves that the universe began hot and dense and has been expanding ever since. It is a photograph, frozen into space-time, of the moment when the first light could move freely across the cosmos. Astronomers have studied its tiny variations, and from them learned the age, shape, and destiny of the universe. This faint glow holds the blueprint of everything that would come. Galaxies, stars, planets, life. It is astonishing that the biggest questions of existence are answered not by blazing stars, but by a soft, nearly invisible whisper in the background. So, when you think of beginnings, don't imagine fireworks, imagine a quiet glow, still arriving, still visible, still whispering. The universe carries its first memory everywhere, hidden in plain sight, waiting for anyone who dares to listen to its ancient hum. How the Big Bang still ticks in background radiation. The universe began in fire, dense, hot, and filled with light too thick to escape. But as it cooled, that first light was freed, and it has been traveling ever since. Today we call it the cosmic microwave background. It is not just an old photograph of the universe. It is still here, ticking quietly, humming faintly, as if the Big Bang never stopped leaving its imprint. Everywhere you look, this background radiation surrounds you. It fills your room. It flows through the atmosphere. It whispers in every direction. It is the leftover glow of creation itself, stretched into microwaves by billions of years of expansion. When you tune an old television to static, a tiny fraction of that fuzz is the afterglow of the Big Bang. The beginning still lingers in our daily lives, unnoticed yet constant. What's haunting is that this radiation carries a pattern, tiny ripples frozen into its fabric. Those ripples were the seeds of galaxies, the blueprint of the cosmic web. From those faint variations, stars formed, planets formed, and eventually we formed. The Big Bang is not history, it is ancestry. It continues to shape us, even now. Astronomers measure these ripples with satellites, mapping the entire sky like a fossil, and what they find is astonishing. The universe still holds the fingerprints of its first heartbeat. The rhythm of the cosmos was set at birth, and it continues to echo in the background, ticking softly through eternity. So, when we say the Big Bang is over, we are not entirely correct. Its light is still here, its rhythm is still here. The beginning continues, woven into every photon that still travels, reminding us that the first moment of time never truly ended. Why ancient light runs slower in expanding space. As the universe expands, so does the light within it. Photons traveling across billions of years are stretched by space itself, their wavelengths elongated, their rhythms slowed. This means that ancient light arrives not in its original tempo, but in a softened, slower version of itself. The expansion of space dilutes not only distance, but time itself. When astronomers watch distant galaxies, they see their flickers arriving more slowly than they occurred. A supernova that blazed for days in its galaxy may take weeks to play out when its light reaches us. The universe, in this sense, acts like a grand, slow-motion camera, stretching events as they travel across its fabric. This stretching is not optional, it is law. Light cannot resist the expansion of space. It rides the flow, it yields, it slows. And the farther it travels, the greater the effect becomes. Galaxies billions of light-years away are slowed to a crawl in our eyes, their events lengthened into patience. We are watching slowed-down versions of cosmic history, not because of technology, but because the universe insists upon it. The beauty of this is that it allows us to witness things we might otherwise miss. Without this slowing, many distant flashes would be too fast, too faint, gone before our telescopes could capture them. Expansion makes them linger, gifting us time to notice. The cosmos itself conspires to share its memories more generously. So when you think of ancient light, don't imagine it racing endlessly. Imagine it sighing, stretching, softening as it journeys. By the time it reaches you, it is slower, gentler, carrying not only distance but the rhythm of expansion itself, the stretching of wavelengths like cosmic sighs. Every photon carries a wave, a rhythm of light. Blue light, sharp and quick, pulses like a fast drumbeat. Red light, softer, moves like a slow hum. As light travels across the expanding universe, its waves are stretched. The quick becomes slow, the sharp becomes soft. The cosmos stretches every rhythm into a sigh, as if every beam of light grows tired on its long journey. Astronomers call this redshift, but there's poetry beneath the math. Imagine light as breath. With each mile it travels, the breath grows longer, slower, more drawn out. By the time it reaches us, it has become a whisper of what it once was. It is not gone, only softened, transformed by space itself. This stretching changes how we see the universe. Distant galaxies glow redder than they truly are. Their light has been pulled, shifted, slowed. They did not choose this disguise. Space wrapped it around them. What we see is not their true color, but the version that expansion allows. Every photograph of the cosmos is tinted by time itself. What's astonishing is how consistent this is. The farther away a galaxy lies, the redder its light becomes. From this, astronomers learned that the universe is not static, but expanding, still growing larger every second. Light revealed not just color, but destiny. The universe forever in motion, forever stretching its own story. So, when you look at a crimson galaxy through a telescope, remember, it did not begin red. It became red through time, through distance, through the long sigh of expansion. You are not seeing its color, you are seeing its journey, painted across the waves of light, galaxies receding and dragging seconds wider. Every galaxy, except those bound close to us, is drifting away. The farther they are, the faster they recede. This expansion is not motion through space, but space itself stretching between us. And as galaxies recede, the seconds tied to their light widen too. Events that were sharp and brief become long and drawn out by the time they reach our eyes. The cosmos itself is dragging seconds wider as galaxies pull away. This is why astronomers say the universe is like a balloon inflating. As the balloon grows, the points on its surface move apart. No single point is the center. Everything expands from everything else, and with that expansion, the seconds connected to light become longer, wider, stretched thin across the cosmos like taffy pulled slowly apart. The implications are profound. It means that the future of the universe is one of widening seconds where light becomes ever softer, ever redder, until galaxies drift so far their glow fades into darkness. Time itself, as carried by light, will stretch thinner and thinner until silence fills the void. Expansion does not just shape space, it reshapes the flow of time. And yet, there is a strange comfort in this, because widening seconds also mean we can watch the universe's story for longer. Explosions linger, signals stretch, history remains visible longer than it otherwise would. Time's generosity grows with distance, gifting us more to see, more to learn, more to remember. So when you think of galaxies receding, do not picture only distance. Picture seconds themselves being pulled wide, history itself stretched across eternity, all carried on beams of patient light. The illusion of cosmic acceleration as time's trick. Astronomers once believed the universe's expansion should slow, dragged by gravity's pull. But when they looked carefully, they saw something shocking. The expansion is accelerating. Galaxies are racing apart faster than expected. The discovery was awarded a Nobel Prize, but it also raised a deeper question. Is this acceleration real, or is it an illusion shaped by time itself? Because when light is stretched, when events are slowed, what we measure may not be the true rhythm of galaxies, but a time-bent version of them. Some scientists argue that our sense of acceleration may be tied to how light carries history to us. We see galaxies as they were, slowed and redshifted, their rhythms distorted. Perhaps what feels like acceleration is partly a trick of perception. This does not mean acceleration is false. Dark energy, a mysterious force, may truly be driving galaxies apart, but it means that our entire picture of cosmic speed is mediated by time. We do not see galaxies moving live. We see their echoes, altered by distance, expansion, and delay. The acceleration we measure is stitched together from ghosts of light, not living reality. This uncertainty is humbling. It reminds us that science, for all its precision, is still bound to the way time filters information. We are not direct witnesses to the universe. We are readers of its diary, piecing together fragments written long ago. What we call acceleration may be both truth and illusion, a blend of physics and perspective. So the next time you hear that the universe is expanding faster, remember that statement is not only about galaxies, it is about time. It is about how the past reaches us, stretched, distorted, and reinterpreted, creating an image that may be part reality, part mirage. Cosmic acceleration may be the universe's greatest trick of time.